Imagine a coin flipping in the air. Normally, when it lands, it is definitively either heads or tails. But picture a world where that coin freezes mid-spin, somehow being heads and tails at the exact same time. That is the strange reality of the quantum world. To understand why that matters, we have to look at the devices we use every day. Right now, the phone or computer you are using processes information using bits. Think of a bit like a row of standard school lockers. Each locker can only be in one of two states: completely open, representing a 1, or totally shut, representing a 0. Every photo, video, and text message you send is made up of millions of these open and closed lockers. Now, let's bend the rules of physics. Imagine a locker that rapidly shifts between open and closed, existing in a blurry mix of both states at once. It only snaps into a single solid state the moment a student actually opens their eyes and looks inside. In computer science, we call this strange, shape-shifting container a quantum bit, or qubit for short. Because a normal bit is locked into a single choice, normal computers have to solve complex problems one step at a time. A qubit's ability to hold multiple possibilities at once allows a machine to skip the line, testing countless answers simultaneously. It allows machines to answer questions that would take a normal computer millions of years to solve. This ability to hold multiple possibilities at once, known as superposition, is the first superpower of a quantum computer. Back in the 1930s, a physicist named Erwin Schrödinger wanted a way to explain how bizarre this concept really is. He came up with a famous thought experiment, which you can see illustrated here. Imagine a cat inside a sealed box. Until you open the box to check, the rules of quantum physics suggest the cat exists in a blur of multiple realities. It is sleeping soundly and playfully chasing a toy at the exact same time. When we swap out that imaginary cat for actual qubits in a computer, the machine doesn't have to guess the right path through a maze by hitting dead ends one by one. Instead, it processes every possible route as a swirling wave of options. The machine evaluates the entire maze at once. It solves the puzzle without having to walk the path. Qubits gain even more power when they are synchronized through a second quantum effect called entanglement. To picture entanglement, look at these two characters. If they are entangled, the moment one character puts on a red hat, a matching hat appears on the other character instantly. They act as a single, unified system. You could place one of these characters on Earth and the other on the opposite end of the universe, and their connection remains perfect. What happens to one immediately mirrors on the other. Because entanglement links qubits into a single massive team, they don't just work side by side, they work together to expand the computer's workspace. Every time you add just one more qubit to this entangled chain, you aren't just adding one more bit of data, you are doubling the total number of combinations the entire system can explore at once. This is an actual photograph of the Microsoft Mariana 1 chip. Researchers are actively engineering physical hardware like this to capture and control these delicate quantum behaviors. By combining the overlapping states of superposition with the instant connection of entanglement, this hardware creates a web of computational power that dwarfs the capabilities of even the most powerful traditional supercomputers on Earth. Understanding the physics is fascinating, but applying that physics to real human problems is why thousands of scientists are working on this right now. Look at this complex molecule. Developing a new medicine requires finding the exact right shape for a molecule to fight a disease. Normal computers struggle with the endless combinations, but a quantum computer can map the exact biological structure in seconds, accelerating the discovery of life-saving cures. That same ability to sort through millions of variables at once can be applied to physical logistics. It could route thousands of cargo ships across the ocean to prevent supply shortages, or direct cars through a major city so that traffic jams never form. Researchers are even planning to model chemical reactions at the atomic level, hoping to design entirely new materials that efficiently pull greenhouse gases right out of the air. We are reaching the absolute physical limits of our current technology. Quantum computing offers a completely different toolset to address the stubborn, deeply complex challenges we haven't been able to solve yet. This technology often sounds like magic, or something reserved only for people with advanced physics degrees. But the true impact of this science will come from a wide variety of people. Students, programmers, and creative thinkers from all backgrounds are already learning how to write the software that will guide these machines. There is an open seat at the table for anyone curious enough to learn the basics and help shape what we build next. Today, anyone can log on to a normal laptop and access a quantum processor sitting in a lab hundreds of miles away via the cloud. The physics are already working in the lab. The only remaining limit on what we can achieve is our own imagination.